All right, in this section, I'm going to show you the basics of soldering and desoldering. So what we have here, this is called a Vero board, and it's basically just a bunch of holes on one side, and on the other side, there's a bunch of little copper pads, and this is where the solder will connect to. So the metal part that a component is basically soldered to is called a pad. And on PCBs, printed circuit boards, there's usually a pad on both sides. In this case, there's just a pad on one side. In PCBs, the pad is connected to traces, and the traces are the metal lines that run around that connect the components. In this case, the pads are just long, and so essentially anything that is touching this line is going to be connected. And so these are set up kind of just strategically so that you can do prototyping or test out circuit designs and schematics. But the reason that I'm using this now is I'm using this to kind of practice, to show off how to solder and how to desolder certain components. So I'm going to turn it around real quick, and I'm just going to put some components just in here. I'm putting these in. These are totally at random. I'm just trying to demonstrate kind of what it looks like when you when you're putting these in, and kind of what it will look like to put them in and take them out. So I'm being fairly, I'm leaving a lot of space. This is a little bit more space than would be in a PCB, but I am doing this so that it'll be a little bit easier to demonstrate. So once I put the lead through, I'm kind of bending it a little bit on the other side so that when I turn it upside down, it doesn't just fall out. So you turn it on this side and you can see the leads kind of sticking out. And now I'm going to try to close up onto the leads that I'm soldering, so that you can get a good look at what I'm doing. You've got your soldering iron, your solder, and what happens is the iron heats up the solder and it turns into liquid. The smoke rising that you see, that's mostly just fumes from the rosin core of the solder melting. It's not lead fumes that's going to give you lead poisoning. You don't have to worry about that. There are, you can be harmed by the fumes if you're doing this all day, every day in an unventilated room, but with proper ventilation and doing it just as a hobby, you're not going to be in too much trouble. So the first thing that we do is we tin the tip, which you just kind of get it a little bit wet with solder. And then what I like to do is heat up the pad and the lead, and then just touch the solder and it should melt. And what you really want is you're trying to get it sufficiently hot. You're trying to get the lead and the pad sufficiently hot that the solder will melt directly onto it and make a nice little it kind of looks like a little pyramid. Or if it's blobby or kind of balled up, it's not good. You want it to kind of be a nice little concave pyramid almost. So I'll do another one here. I'm heating up the pad and the lead. Touch the solder. And there, we got a nice little solder joint there. I'll do another one here. I'll do a few of these, try to make it so that I can kind of give you some light. So I'm being a little bit messy right now because I have a lot of space to work with. When you're working on a PCB, you might have a little bit less space, but this is a really good way to get started. You don't want to start on a really tiny little PCB because you'll be out of practice. And honestly, you got to have good skills to do the little PCBs. And let's do the last one over here. So again, these aren't connecting to anything. This is just for practice. Okay, so I might do some close-ups in post, but yeah, I get a little close and you kind of see how that looks. These are nice and strong and they're in there. So typically after you've done this, what you would do is you cut off the leads And I'm going to do this for the sake of realisticness. And the next thing we're going to do is desolder. Now, desoldering is the hard part. It's actually a very useful skill, removing components, because when you're working with old equipment, the electrolytic capacitors tend to fail. Components can fail, and so you want to remove them and replace them. Now, really a skilled technician should be doing this, but with enough practice and some know-how, you can kind of learn to do it yourself if you don't have a technician handy. So here are our 3 components that we are going to try to remove. So you might think that it would be good, you just want to go in there, desolder, and start pulling, but the thing is, it's really hard to do that, because you can, unless you have like if you have a nice long soldering iron and a lot of space, you can kind of heat both pads up at the same time. You can heat both these up at the same time and then yank it. But usually in a PCB, you don't have a lot of room for that. So what I'm going to do is I'm going to cut these off, leaving as much space as I can up here. Then I'm going to grab, hold there. Let's see if I can line this up so I can see and show you at the same time. Yeah, I think this is going to work a little better. I'm going to grab onto this here and then heat this up here and give it a little pull, and it comes right out. Do the same here. There you go. Now, I realize this is not super realistic. Sometimes you really can't get in there and clip these off because they're soldered so close to the board. And if that's the case, you're going to have to use this tool, which is called a solder sucker. So I'm going to push the button in, heat up the solder, and then push the release button, and that will suck in a bunch of solder. And so you'll see, basically I'm able to suck up all of the melted solder, or some of it, enough to kind of pry the one in. So I'm going to try that with this, and I'll show you how that looks. Heating this up. Oh, didn't engage it. All right, heating it up. And I'm going to do it again, just to make sure I get as much off. I'm going to do it again. Here we go. And that might be enough for this guy to come loose, and it is. So it's come loose, and I'll show you that again with the resistor that I have in there. Let's see if we can get this in here. So I've got my solder sucker. I push the plunger down to engage it. This button will release it. When I release, all it's doing is creating a vacuum and sucking up a bunch of air. I'll do that again here. And that should be enough to get this guy loose now. And here you go. So that's kind of what it looks like to desolder. Here's my tool bench. To show you the solder sucker, again, kind of in zoom out mode. When I push in, it engages. When I push this button, it disengages. If I hold my finger here, when I disengage, you'll see it doesn't come out all the way. It's because it can't suck in. There's the air. And let go of my finger, it goes. So really what you're doing is you're pushing the plunger down. You press this button, and then as you press the button, the plunger comes out and sucks the air out. So they make really nice ones of these that have a soldering iron built into them. And that's really the easiest way. So I'd say if you plan on doing some recapping and you haven't really mastered this skill yet, you can buy a nice tool that will really, really help. But that is how to solder and desolder. I would say if you want to practice this skill, get one of these guys, a little Vero board, and start just soldering a bunch of components in, and then try desoldering them. This is one of those skills that you just learn by doing, and doing it all the time. At this stage, we are going to be testing out all of the components, or testing out the components that we can, and have them all laid out. So as you can see here, I've laid out every single component on this piece of paper. This is a really nice way to get started with any project. This is a very small project, so it was fairly easy to put all of these onto a single sheet of paper. Sometimes projects will have hundreds of components, and in that case, you may not have the time or the patience to do this, but getting started, and when you have a small project like this and you're just getting started, it's a really good idea to do this. So what I've got here is a multimeter. This is a multi-tool. It measures a number of different electrical components and things about electrical components. So basically what I'm going to do is I'm going to walk through all of the ones that I can test and make sure that they are what they are supposed to be and what they say they are. Some components can be poorly made or be broken, and then they won't do what they're supposed to do, and then it's really hard to troubleshoot why something is broken when that's the case. So first, to turn this on, there's a bunch of different modes. So one really useful mode we're not going to use right this second, but this little sound wave here, this is actually just a continuity meter. So when the circuit is completed, it beeps, and that's a good way for checking if you maybe soldered something incorrectly and you're completing a circuit that shouldn't be completed. But for now, we're going to start by putting it in the ohm mode. And so this ohm symbol here, that is the symbol for resistance, and these parts all here are resistors, so we're going to check that their resistance matches with what it's supposed to be. So here we have R1, which is supposed to be 1 kilo ohm, and I pop on the pieces here, and we're at 0.989 kilo ohms. So that's really close. None of these components are going to be dead on. Very rare that things are dead on. Very expensive components are dead on, but these are kind of just cheap components, and that's why, that's kind of the difference between a really nice piece of electronics and kind of a cheaper, is that the components are cheaper and thus they'll be slightly off. But okay, so we know that these resistors are good. So coming up here are our variable resistors. Now, I'm sure you've turned a knob in your life before. So a knob, a lot of the times on electrical components, at its most simple, a knob is just a resistor. And you'll notice that so these have 2 leads, one on each end. These have 3 leads, 1, 2, 3, and 1, 2, 3. So what happens is the outside 2 leads are always have the same resistance between them, and then the center, when you turn the knob, the resistance between the center pin and the outside pins change, and the resistance between the left 2 pins and the right 2 pins is always going to add up to the total resistance. So here we have R2 and R7 that are 50 kilo ohms, and I have var here for variable, 50 kilo ohms variable. So if we check the 2 outer pins, we should get just about 50 kilo ohms there. And same here, we should get just about 50 kilo ohms here. Sorry, it's a little hard to do this. All right, and so I'll try to get a little more sturdy. 50, let me get the wire out of the way 1 second. All right, so we've got 51.6 and we've got 49.6. So yeah, they're off by a little bit, but they're pretty close. And then here we have R8, 100 kilo ohms variable. That should be 100. It looks like it's 109, a little high, but again, these are inexpensive components. So now to show off the kind of the variable portion of them, I'm not going to test all of them just because this is a little clunky to do, but what I'm going to do here is take my alligator clips, which are just going to let me clip on to these guys without causing, I just have to make sure that they don't touch. This is not super easy with these. Let's see. Okay, I think I got it there. And then I'm going to attach one of the alligator clips to that lead and the other alligator clip to this lead. And here we can see we have 34. So if I turn all the way in this direction, I should go all the way up to 100. And if I turn all the way this direction, we go all the way down to 0, or at 2.6, close enough to 0. So you can just see that the resistance changes as I turn the knob. And I can't really demonstrate it very well with this example, but keep in mind that when this is all the way to the right, and the resistance between the right and the center is 100, or 110 in this case, the resistance across the bottom, the middle, and the left is going to be 0 or close to 0, and then it'll change and it'll start to go up here. So that's just the way that these work. You can actually, interestingly, on my voltmeter, on my multimeter, you can see that little bar running up and down. So yeah, that's how these work. So that's the resistors. The resistors all match up. I mean, again, these are a little off, but that's the magic of inexpensive electronic components. So next we have capacitors. So when we're want to measure a capacitor, this little symbol right here is a symbol for capacitor. And so what I'm going to do is I'm going to turn that. So the white symbol is a symbol for a diode, and the yellow symbol is a symbol for the capacitor. So I'm going to set it to this one and then press my yellow button here, and I'm now in capacitor test mode. And so what I want to do is put the leads on these capacitors. So there's capacitors here and there's capacitors here. So these capacitors are polarized. This leg is longer than this leg. That leg is longer than that leg. That leg is longer than that leg. The longer leg is the positive leg. These capacitors, you can't see the ends of the legs, but they have the same length of legs. These kinds of capacitors are not polarized. Doesn't matter how you hook them up, they work the same. With capacitors that are polarized, it's very important that they be put in the circuit according to their proper orientation, or they will explode, actually. And the very first time I soldered a capacitor, I did it wrong and it exploded, and luckily I was wearing safety goggles. And it saved my vision. Otherwise, I honestly could have been pretty severely injured. So the way I have my multimeter set up, and I'll just show you here. So the black is going to, it says COM here. That's common, another word for ground. So generally, if you have two leads, the red is hot and the or positive, and the black is cold or ground. So now that we have, so we're saying red is hot and black is ground. We know that we can put the red against the positive pin and the black against the negative pin. It's not going to be enough to damage it if you do this wrong, but it's good practice and it's best for your equipment and for your components. So what I have here is I'm getting 98.1 microfarads. The little U, kind of backwards U, is micro. And we see here this is 100 microfarads. So that checks out right there. Next, we have C3 and C4, which are both 10 nanofarad, or 10 microfarads, sorry. And so let me just get this wire out of the way for you. We'll put this down here, and we've got 11, and we've got 11-ish. So yeah, so these all check out. This is 100 micro, and these are 10 micro. So now we'll move on to these other capacitors here. Again, these don't matter. The orientations don't matter as much, but this is C2. So this says 104 on it. Sorry, one second. Let me adjust the microphone. So you really can't see. It's very difficult to see. I'll try to show a close-up of this, but this says 104 right here on it. This says 105. That's what I have in quotes is what's actually printed on it. That's the capacitor code, essentially. The way that you read that is the first number here is the first digit of the value. This is the second digit of the value, and then this is the multiplier of the value. I'll show you a chart for that, but 104 translates into 100 nanofarads. And if I do this here, you'll see I have 95 nanofarads. It's maybe hard for you to see, but the kind of the scale, the value of the digits, it shows up right here. This says NF, nanofarads. And so we've got about 100 here, 96. And I actually cannot measure this last one, 100 picofarads. That cannot be measured with this tool. Tool is just not detailed enough to get that. So fortunately, that's just the way the cookie crumbles on that. So that is us now having tested all of our components that are testable. We've tested them and we know they're good. So we're kind of good to move on. Before we continue, I'm going to show you here. This is a XR2206 IC. It's essentially a signal generating IC. So an IC is an integrated circuit. Anytime you see one of these little kind of black bars with a lot of little pins sticking out of it, that's an integrated circuit. They do a number of things. Essentially, if you want to know more about what it does, you look up the number and you can find the data sheet online. Some people, have these memorized, but you're not going to be able to tell what it does unless you look it up or you have the numbers memorized. But they can be amplifiers, they can be timers, they can be delay chips, they can be filters, they can be oscillators, they can be any number of things. In this case, what we have is we have a generator. It's essentially an oscillator. It's going to be creating the signal. Then this right here is a socket. It's not a good idea to solder these guys directly into your board, because if you make a mistake, it's really hard to get out. So what you want to do is you have the socket, and then you can pop these in and out as needed. Right here is just some headers. All this is literally just some leads, and I'll demonstrate later. We know what we do with them. These are jumpers. What we're going to do here is kind of just connect these leads with these jumpers, and that's how the settings on this thing work. You basically adjust the settings and the frequency range with the jumpers. Right here is a signal terminal. So this is the output, actually. If you saw my webinar on terminal connections, this is a similar kind of, just a kind of a different shape. But basically, you have these three outputs, and what I'm going to do is I'm going to connect a cable to these so that it's easier to come out of. But again, this is sort of a cheap device. It doesn't have a nice standardized cable. The wave signal is going to come out of this. And then here's our DC jack. This is just what we plug into power. And this works with any 9 to 12 volt power adapter, DC power adapter. And I've read online that the 9 volts works best. So that's it. We've tested. Let's move on. Okay, so now we're getting started on the part where we're actually going to start building the circuit. So I just wanted to lay out the tools that I'm going to use here and talk about them for a second. So here I've got some needle nose pliers. This is just good because these are really nice and long and slender, so I can really get into little parts to bend something or to take a component out if I screwed up. These are little snippers. These are really nice because as you can see, these leads are kind of long. And when I pop something in and it's done, I'm going to snip the end off. That'll make it nice and have the ends be short so they're not touching each other. Here's wire strippers. I might not actually need these, but I like to have these around if I have to strip some wires. This is a solder sucker. Basically what it does is you pop it in and then it makes a vacuum. So if I press this button, it kind of sucks the air in. So you can see if I put my finger on the top and I press the button, it doesn't retract all the way because I've created a vacuum. And what you do is you use this to suck up any solder that has kind of like built up if you need to remove something. And then here we go, we have some solder here. So solder is lead and rosin. This is rosin core. This is a 2% flux core solder wire. So basically the lead melts. The rosin inside of it is what helps it stick to the metal. There is lead-free solder out there. It doesn't work very well. It's very hard to use. I really would suggest getting the leaded stuff. I really like this blend here, which is, I don't know if you can see this, but it is SN63PB37. Great stuff. Okay, and then of course I've got my soldering iron. So what's great about this little setup that I have here with the soldering iron is I've got this tip cleaner. Let's see if you can see this. So what this does is when the tip gets all gunky and screwy, I can pop it in here, and this stuff, there's a bunch of rosin in the bottom and these these braids that are coated in rosin, and it makes the tip nice and clean. So that's what I'm going to use kind of between, when I make a mess, inevitably make a mess with the solder. That's what I'm going to do. So then what I've also got here is the circuit. So it's my PCB, printed circuit board, and I've got this right here is called a helping hand. This thing is extremely useful, especially because I can use it to turn the circuit around and turn the PCB around, get onto the bottom. I can easily switch between it being sorry, on the bottom or the top, and it holds it nice and steady for me. You can do projects without these. I've done many projects without these, but wow, they're very, very helpful. So I've got my pieces all here, ready to go. Let's get started. The first thing that you want to do is identify, the parts that need to be soldered. So we can just go in order. I've got that sheet, as you remember, that had the components labeled. So I like to start with the resistors. The resistors are small, and they're just going to kind of sit very close to the board. A lot of instructions will tell you start with things that are small and that are going to sit across the board. So the resistors, you can see they have that little shape like that. That's where a resistor is going to go. That's where a resistor is going to go. There's some resistors that are going to go there and there. And starting with R1, finding R1, there's R1 right there. And we have R1 on our little piece of paper that we can grab. So let's get started with R1. All right, so I'm going to pop R1 into, there we go, sorry, try to stay out of your way. So now we've got R1 in there. If I'm going to disconnect this, I'm going to turn this around so you can see the back side. And what I like to do is kind of stretch them out like that. You got the two ends there and there, kind of get them stretched out so that it can stick itself, kind of stays in there. And then we got to do the soldering. All right, so I'm tinning my tip. And then what I'm going to do is I'm going to heat up. So the little metal circular bit that's here, that's kind of in the hole, that's the pad. That's referred to as a pad. And I'm going to heat up the pad and the leg, and then my solder should just melt nicely to both. And I'll do it over here too. And there, as you can see, we've got a nice little soldered joint right there. Then I'm going to take my clippers, clip there, and clip there. And we've got our first resistor in. Right there. All right, look, now we have all 5 resistors soldered on. All right, so coming up next, we're going to do the capacitors. All right, so here's one of the capacitors. This is C1. This is 100 nanofarads, or 100 microfarads, I'm sorry. And you should be able to, if I can get the camera to focus, see it right there. It says 100 microfarads. Again, we have the longer leg is the positive leg. So this is C1. We're going to find C1, which is right here, right there. And the positive leg is going to go in, excuse me, I'm sorry. I need to figure out where the positive leg goes. I believe the positive side is going to be the dark side, but let's take a pause and figure that out with these diagrams. I'm used to the diagram having on it either positive or negative, not dark or light. Okay, so I did a quick Google search and saw that the shaded side is the positive side. So we're going to take the long leg again here, so you can see one leg is long and one leg is short, and we're going to make sure that the long leg goes in like that. And And I'm going to stretch the legs out a little bit on the back side, so when I turn them around, ooh, see, I just made a little solder bridge there. So that's a good lesson. So you see, I kind of connected those two together by being messy. So that's why I've got this. So I'm going to get the solder sucker put right here, heat this up, pull the trigger, and I've now kind of unbridged that connection. You can see there's no longer solder connecting those two. Cool. What's next? Let's do the other capacitors. So the other capacitors are all going to go here-ish. You can see these, when you have the capacitor symbol with the two lines like that, that means that, again, they're not polarized in any way. So we just have to make sure that they go in the right spot. So I'm going to grab C2, and C2 is going to go right there. So let's pop C2 in. And then I'm going to stretch the legs out on the back. And there we go. C2 is in. And these guys tend to be a little loosey. So I'm just loose rather. I'm just going to just be really careful when I turn them upside down. I don't want them to fall out. That would be a real pain. I will show you a trick later on how to, with kind of other pieces of electronics and how we can kind of keep them in. So as you may be able to see all the kind of leads coming out there. So now I'm going to ride up and kind of just start soldering all those leads. This one right here is not super strong right there. So I'm going to just get in there with the soldering iron, give it another go. I can kind of bend these leads out of the way a little bit now that they're soldered in slightly. There we go. All right. So now they all look nice and strong. This one's a little ugly. Sorry, my soldering skill. This is like tying somebody else's shoes a little bit. So now I'm going to clip these all off. That one that I said that I fixed is it's still a little ugly. So this is kind of tricky, but I'm going to try to get in there and fix it up a little. All right, it's just a little nicer now. Not quite as ugly. So now I turn this back around. I have now got almost all of the smaller components in there. So I've got all of our, all right, I've got our resistors, our capacitors. So the next step is going to be staying stuff with low profile. I'm going to put in the socket, the IC socket, and that's going to go right here. So what's cool about the way that they print they screen print the circuit board is that you'll notice this guy has a little crescent moon at the top, and that matches the little crescent moon, the little indent at the top of the screen print. It can be a little difficult to see. If you can see there, I'll try to make that obvious. So the bottom you can see is flat, and then this has a little crest. The bottom is flat down here, and the crescent moon is right up there, and that matches little crescent moon right there in the bottom. So I'm gonna pop this in like so, orient it like so. Come on. Oh, and the reason it's not going in, of course, is because there's two bent pins. So I gotta bend those pins back into place. These pins are rather fragile. So then let's give it another go and be a little more gentle this time. I'm gonna just disconnect this and do it close to my face. All right, now that I've got it in, what I'm gonna do is take a piece of that blue tape that I've been using, this kind of painter's tape, and I'm just gonna use that to hold this in place, because otherwise it's gonna fall out when I turn this upside down. So now I can turn it upside down, and it is still in there because of the tape. And now I'm going to go through and solder it. Without that, the reason I like to use that blue tape is that it's low tack, and it's not going to leave any kind of goop or gunk behind. Now let's get in here. Okay, I've got that done. That was probably the biggest one that's going to happen this whole time. All right, so I'll turn this back around, take the tape off, nice and in there. And now I can just actually pop that IC. Well, you know what? I'm not going to put the IC yet. I like to wait until we do all the soldering to do the ICs, because they can be damaged very easily. So the next thing I can do is populate this little header board right here, and I'm gonna pop that in. All right, so we've got the headers there. Again, I'm gonna do the same thing I did before with the piece of tape. I'm gonna tape this guy down, and that is because it'll just fall out if I don't have it taped in. But this tape isn't gonna leave behind any gunk. So now I've taped that down. Let's turn it around. Right, got it right here. I gotta make sure the tape keeps it nice and flush, or else it's gonna be really tough to solder in. So these kinds of little physical problems, these are sort of some of the harder parts about doing this sort of work, is just making sure that you can keep everything physically organized and well aligned. All right, I got those all soldered in. Let's turn this around and make sure it's nice and sturdy. Get this out. Alrighty. I was cutting it pretty close with that, but these are in. You can see there's a lot of clearance there, but they are in there, so we should be good. All right, let's do it again with the smaller one here. That's gonna go right here. And let's tape it down. Now we have only a few things left to do. So let's start with the signal terminal. So we can pop that in. So the way we want to orient the signal terminal is we want these kind of silvery bits where we're going to connect the wires to face out of the board. That's away from the board. So I'm going to pop it in there. And yet again, need to use a piece of tape to hold that down. All right, moving on. What's next? We've got the DC jack. So the DC jack is set to go right here. Pop it in. Get a piece of tape ready. All right. And that's it for the jack. It's now in, nice and solid. So we've got these resistors right here. So we've got R2, R7, and R8. Those line up with R2, R7, and R8. So we can pop these in. Now these have these little kind of hook guys that make them stay in when you put them in. Well, they usually stay in, not these. I'm gonna kind of pull the metal out just a little bit, and that'll help it stay in a little better. I might need to do the tape trick with these too. So I've got the leads soldered in now, and then these big chunks right here can be soldered in. They're basically just support so that the user can kind of yank on them and they don't get damaged. But it's good to solder that in too. So we have completed putting the circuit, soldering everything together. The last thing to do is going to be to pop this guy on. And so the reason I was talking about that crescent moon earlier is there is that little crescent moon right there at the top. So this bottom part is flat and that top part has the crescent moon, and that's how you know how to orient this when you pop it in. And these legs, I'll tell you what, they can be a bit of a pain. So what I like to usually do is kind of push them in slightly, not too much, or else you'll destroy them, which I'm on my way to doing. You have to be very gentle with these. If you break a leg off of these, you're kind of sunk until you buy another one that comes in the mail a week later. So get them all in. And they pop right in. And it's always good to do a double check and make sure that all the legs are in there and that they didn't get bent up. Well, now that I've soldered everything together, we're going to pop it into the case. So remember how earlier I said that if you don't put electrolytic capacitors in correctly, they explode? Well, it happened. The one internet resource that I looked up to see if the shaded side is positive or negative was incorrect. And according to some other resources, the shaded side is, or sorry, the resource I saw said the shaded side is positive. However, the actual orientation is that the shaded side should be negative. And we know this because I plugged the shaded side in as positive and this capacitor exploded, and that fuzzy stuff that's all over, that's the inside of the capacitor. So that's no good. This capacitor is now useless. Let's see, we just kind of pop it off altogether. So what I'm going to do now is I'm going to carefully take all three capacitors out. It is now, I'm not going to show you, how I did this, but it's all assembled now and it fit together. It's just pieces of plastic screwed together. But so this is the output right here. But again, as we had discussed, this isn't really a super normal output. So what I'm going to do is I'm going to take this cable and I'm going to rip it apart and show you how to get it out. So this is sort of similar to the last workshop that I had done about the 575. But what I'm going to do is I'm going to use my snippers and snip this end off. And now I've got two RCA female connectors. These are pretty useful. And then what I'm going to do is, let's see, like I need, a good amount. I don't really need a ton, but so I'm gonna give myself some, got the leads here. So I've got the braided cable that is on the outside here. that's going to be the ground. That's connected to the ring here, which is the ground. And now I need to kind of get some, need to adjust this so that it closes a little smaller. And there we've got one of them like that. And then also I'm going to do two at the same time. I'm going to have two coming in. So I don't know if you can see here, this says ground sine, or ground square sine triangle. So the way that this works is this is the common ground. This terminal is going to send out the square wave signal, and this terminal is going to send out the sine and triangle signal, and you switch the sine and the triangle signal between those two using that little guy here. So what I'm going to do is I'm going to have one of these send the square, one of these send the sine triangle, and in order to do that, I want to have their grounds connected. So I'm going to make another one here. And so let's see here. Braiding this up, and now we've got these two, and the grounds, all grounds in general are connected to each other. So I'm gonna actually go ahead and just connect the grounds here, and that way I don't have to worry about, you know, the grounds are now just connected to one common lead, this here, and then this white one is connected to the black cable, and this yellow one's connected to the red guy. And as I had, again, this is maybe a little bit of a refresher, but I am going to tin these tips. First, I'm going to just kind of tie them together. I'm just what I'm doing is I'm just twisting the ends so that the ends don't fray. When you get frayed ends, it really is a big pain. This is, I'm sorry if this is just kind of a weird thing to record on video. I'm not quite getting it. All right, here we go. So I've got my soldering iron and I've got my solder. It's heating up right now. There we go. It's heated up. All right. So now when I have that, I'm gonna I'm gonna set this here so it's just a little bit raised off. What I'm doing here is I just want to raise the cable slightly so I don't burn my tablecloth, and then I'm just gonna wipe some solder on here. And this is just for structural integrity. This isn't required by any means, but it's really helpful when you're working with these terminal connectors. See, I just kind of bumped these and they frayed, and it's really hard to get stuff in the terminal connectors when it's frayed like that. So that's why I'm just gonna tin them up like that. And they'll have a lot more structural integrity once I've done that. Okay, so I need these screwdrivers because these screws are very small, and this is the special small set of screwdrivers. So pop this open, grab this guy right here, and it looks like that fits. All right, so so this is the ground. As I unscrew, it sort of loosens that, makes a space for me to pop this guy into, and then I can tighten it. And now that's nice and sturdy. So next I'm gonna put the white cable from the, I'm gonna put the white lead in the square. It's gonna be a little tough. See if I can get that and show you at the same time. And put the red as a yellow lead into here. Get those in. And then screw it in nice and tight. And I'm going to use these handy dandy, extremely slender needle nose pliers. Sorry if this isn't exactly the clearest view. All right, got that in there. Screwing it in. All right, and now I've got my connections. So this black one is going to send out the square wave. This red one is going to send the sine or triangle wave. And now let's hook it up to the waveform monitor. Right now, what we're looking at is the square wave and the sine wave in an oscilloscope. So I've got the square wave hooked up here, the sine wave hooked up here. The sine wave is going into channel 1 of the oscilloscope, and the square wave is going into channel 2 of the oscilloscope. So channel 2, I can adjust size, the amplitude there, or the scale there, and channel 1, the sine wave, I can adjust the scale here. So as you can see, they're in sync with each other. This is just has one clock. The one clock is generating both of the waves, and I can adjust the amplitude of the sine wave, and I can adjust the frequency. And yeah, so basically that's adjusting the frequency, the coarse adjustment, and then this is the fine adjustment. So you can see it's kind of hard to get it to really kind of sync up with the scope, and that's what's one really interesting thing about this. So one way we can view both the channels, the sine wave channel and the square wave channel, at the same time, but it's kind of hard to sync up. Or we can use the square wave channel. So real quick, the square wave, it just looks like, you know, a high and a low, and you're not seeing like the rise and the fall. That's because it goes down so fast it doesn't have a line. It's just kind of high, low, high, low, high, low. And then this is kind of, they're going at the same frequency, but they're different wave shapes. So you can use the square wave as an actual external reference for the scope. So let's show you what that looks like. I'm going to take the square wave from the channel 2 in and put it into the external reference. And you see it locks up. So I'm going to turn off channel 2 view right now, and we'll just view channel 1. And now the scope is being timed by that square wave pulse, which is at the same frequency as the sine wave, and now it's always going to be locked up. So now when I adjust the frequency and I make the frequency higher, you see it's actually affecting the wave, and that's like basically too fine for you to see. And I can adjust the frequency, coarse adjustment here, fine adjustment here, and the amplitude adjustment here. But you know, there's not really too much to look at here. I just kind of want to show you that we made a working tool that is working as expected. Even after the capacitors blew up and we had that problem, we were able to put it back together and get it working. So it is doable, and a little kit like this can be really helpful in kind of teaching you how to solder.